Hello, class. We're about to start lesson 1-1, given 110%. According to our syllabus, lesson 1-1 will start off on page 3, problems 1 through 13. And as you see here, this is actually page 3. However, problem number 1 does not start until we get to actual page 4. Now, with problem number 1, it says using the fact that percent means per 100 or per 100, write 84% and 9% as fractions with denominator 100. So 84% is 84 per 100, or 84 divided by 100. And 9% is 9 per 100, or 9 divided by 100. Now, in this case, this is one of those rare cases where we wouldn't simplify, but basically from here on out, we will be simplifying any fraction that you come in contact with, unless otherwise stated. Now, we scroll up here. It says, here's a simple rule that can be learned from question 1. If you notice, converting a percent to a fraction. To convert a percent to a fraction, drop the percent sign and use the percent number as the numerator of a fraction whose denominator is 100. If you notice that the fraction in the first part of your answer to question 1 could be reduced, good job. When we're working with percents in fraction form, many times it would be easier if the fraction is reduced to lowest terms. It says number 2, convert each percent to a fraction in lowest terms. So we have 42%. So first we will write that as 42 divided by 100. And then now we will simplify this. We will ask ourselves, what does 42 and 100 have in common? We could divide both by 2 because they're even. And we will be left with 21 over 50. And we're done. Now for B, it says 37.5%. Hint, after initially writing as a fraction, multiply by 2 halves so that the numerator and denominator of your fraction are both whole numbers. So basically what this is saying here, this 1/2, if we put it in a calculator, will give us 0.5. So this is really 37.5%. Now we're going to rewrite that as a fraction as 37.5 divided by 100. Now, according to these directions, we will multiply this fraction by 2 over 2. Now, we know from previous math classes that whenever you have a number divided by itself, it's really 1. And anytime you multiply by 1, you're not actually changing the problem. So 37.5 times 2 will give us 75, and 100 times 2 is 200. Now, 75 and 200 both has 25 in common. So we'll divide both by 25, and that would give us 3/8. Now we move on down to problem number 3. It says here, often it's especially useful to write a percent in decimal form when doing calculations. So let's see how that works using what we already know about fractions. We know that we can write 12% as a fraction in the form 12 over 100 and 72% in the form of 72 over 100. Use a calculator to perform the division in each case, writing the original percent in decimal form. Okay, class, we're going to use the app called Desmos. So we would click on the Desmos app, and they ask us to use a calculator to perform the division in each case, writing the original percent in decimal form. So we have here 12, well, first, we have here 12 over 100. So we'll take 12 divided by 100, and that would give us 0.12. And then we also have, for the next value, we will have 72 divided by 100. And that gives us 0.72. So we'll write this 12 over 100 is equal to 0.12. And we'll write 72 over 100 is equal to 0.72. But one thing I did leave out, and I'm going to go back and correct this, is that I should have wrote the 12% first. 12% leaves us to 12 over 100, which leaves us to 0.12. And then here, this would be 72%, leaves us to 72 over 100, which is 0.72. Now, one other thing that I did not show in the previous problem, which I want to correct now, is this here. If we go back to problem number 2, let's go back here to problem number 2. Okay, now, when we did our 42 over 100 and we wanted to simplify, Desmos can actually make that a lot easier. Desmos can actually do the simplification for you, and I will show you that right now. Okay, so we're going to type in 42 divided by 100, which gave us the decimal. Now, if we wanted our answer in a simplified fraction, you see this little circle here with this block divided by a block. If you hit that, it will actually give you the fraction as well. It actually skipped down a little bit. So when you hit that block, it will give you the fraction. You can hit the block again, and then it will give you the decimal. So that's a way of simplifying a fraction. So let's take a look back at B. If we took 37.5 and divided by 100, and then you notice we have our decimal here, which is 0.75. But if we hit our block here, I don't know why it skips down like that when you hit the block, but it's 3/8. Okay, which is what we got for B. All right, now we're going to go over here to page 5. So we have number 4 here on page 5. And it says, use the result of question 3 to fill in the blank in our next rule for converting percents. It says to convert a percent to a decimal, drop the percent sign and move the decimal point 2 places to the left. Now we're going to practice this. It says write each percent in decimal form. So we have 41%. And we want to rewrite this as a decimal. So we would drop the percent sign. And remember, the decimal is assumed to be behind this 1. So we'll move it to the left 2 places. And it will give us 0.41. Now with the 6.7%, again, we had 6.7%. We would drop this percent and move this decimal 2 places to the left, and it'll give us 0.067. And finally, 120%. We'll drop this percent sign. It's assumed to be a decimal at the end. We'll move this decimal 2 places to the left, and it's 1.20 or 1.2. You don't have to add the 0 at the end. Okay, number 6. It says, sometimes interpreting the story told by a percentage will require a conversion in the other direction. Starting in decimal form and converting to percent form, not surprisingly, we accomplish this by doing exactly the opposite of the steps we did for converting from percent to decimal. It says the opposite of moving the decimal 2 places to the left is moving the decimal 2 places to the right. The opposite of dropping a percent sign is adding a percent sign. Now, we are going to practice this a little later, but let's take a look at number 7. It says, write a procedure for converting a decimal to percent form, then use it to convert 0.34, 0.7, and 1.658 into percent form. So we will move the decimal to the right 2 places and add a percent sign at the end. So now, in practicing this, let's take the 0.34. So we would have to take this and move the decimal 2 places to the right. So that would give us 34, and we'll put our percent sign at the end. Next, we have 0.07, and we would do the same thing. Move it 2 places to the right. We add 7 and put the percent sign at the end. Finally, we have 1.658. Move the decimal 2 places to the right, which would be 165.8, and put the percent sign at the end. Okay, so now we need to move on to the next page, page 6. Now, it says here, in the most common calculations involving percents, the goal is to find percentage of some quantity. To understand how to do so, consider the following example. You probably know that 50% of 10 is 5. Let's rewrite that statement, then turn it into a calculation. 50% of 10 is 5. We would change the percent to a decimal. Of means multiplication, and we have 10, and it equals 5. When writing a percentage statement in symbols, the word of becomes multiplication, and the word is becomes an equal sign. Also, we need to change the percent into decimal or fractional form. Let's look at some sample calculations using this idea. A restaurant was running a fundraiser tonight for the local food bank in which 30% of every purchase was donated for food relief. If my wife and I spent $24.59 at the restaurant, how much was donated? So number 8, fill in a blank to describe the calculation described above. So basically with the percent, it was 30%, which we have here, of, and then it says of every purchase. So the purchase was the $24.59. Is what amount? Now, the what amount, actually, it did not tell us the what amount, so we have to figure the what amount ourselves. So, it asks us in number 9, what was the amount donated? So basically, we'll write this as an equation. It'll be 30% of means multiplication, 24.59 is, which is equal, and what number we don't know. So now, we would change this 30% to a decimal. We'll drop the percent, move the decimal 2 places to the left. It'll be 0.3 times 24.59, and that equals x. So now we will put this in our calculator. Go back here to using Desmos. So we would take the, guess I really don't have enough space here, but see if I can squeeze this calculator in. So we have 0.3 times 24.59, and that would give us 7.377. Now remember, we're dealing with money, so we typically only go 2 places behind the decimal, so it'll be 7.38 with rounding. So it'll be $7.38 is equal to X. So now, it says the same idea can be used for other calculations involving percentages. Like this one, a closeout store is advertising leather jackets at 70% off the original price, which means the sale price is 30% of the original price. If one jacket has a sale price of $59, how much did it cost originally? So number 10, it says fill in the blanks to describe the calculation described above. Now if you notice here, it tells us that the sales price is 30% of the original price. So we would have 30% of what amount is $59. So we have our percent, and it's $59. Okay, so now based on your answer to question 10, set up and solve an equation to find the original price of the jacket. So we would have 30% of X is equal to $59. This is write number 10 out as an equation. So we would change 30% to 0.3 or 0.30 times X is equal to $59. So now we would take our 0.30X is equal to $59 and divide each side by 0.30. Now when we put this in our calculator, X is going to be approximately $196.67 when you put it in your calculator. Okay, so now we will move on to page 7. Now, page 7, we have another example here that we will be needing to do. It says, guess what? The same idea can be used to find a percentage, but it's more straightforward to use division. For example, of the 32 teams in the National Football League, 12 make the playoffs each year. What percentage of teams make the playoffs? It says, number 12, divide the number of teams that make the playoffs by the total number of teams and write your answer in decimal form. Okay, so we have the number that make the playoffs, or the number of teams that make the playoffs, and then we have the number of teams. So the number of teams that make the playoffs, told here is 12. The total number of teams is 32. Now, if we put this in our calculator, I'll just bring our calculator real quick. And let me clear out some of this real quick. Yeah, good. All right. So now we would take 12 divided by 32. Now that gave us a decimal, but well, they did ask us to write it in decimal form. So it'd be 0.375. So that's our answer in decimal form. Now it says, based on your answer to question 12, what percentage of teams make the playoffs? Now remember, to change a decimal to a percent, we'll move this decimal 2 places to the right and put a percent sign at the end. So we add 0.375, move it 2 places to the right, and it'll be 37.5%. Okay, now we're going to move to the second part of our syllabus, which starts on page 8. So, on page 8, we will start our second set, which will be problems 1 through 13. Now, we cannot do number 1 because, again, we're meeting online here. So we will go down to number 2. It says, number 2, let's look further into the idea given 110% effort. First, explain why a lot of people feel like saying that doesn't really make sense. Okay, now the reason why that doesn't make sense is because 100% is everything. You cannot give more than everything. Now, it sounds nice to say I gave 110%, but whatever you give, the max, and when you go up what seems like above and beyond, that's still just 100% of your effort. You can't go past 100% as far as effort. Okay, number 3. It says convert 110% into decimal form. Then multiply the result by 200 to find what 110% of 200 is. So this is what we would do. We would first write 110% as a decimal. So we would drop the percent sign, and you know it's assumed to be a decimal at the end. We'll move it 2 places to the left, and it'll be 1.1, or you can write 1.10. So this is 110% as a decimal. Now they want us to take this value and multiply it by 200. When you put this in your calculator, it'll give you 220. Okay, now, number 4. Suppose that in a normal half hour of practice, a tennis player expends 280 calories of energy. How many calories would she need to expend if she were to give 110%? So basically, you would take the 280, which is the 100%, and then you want to give 110%. So we'll have to multiply this by 1.1, which will give 308 calories. Okay, now we move on to page 9. Now with page 9, we have another example here. It says, now let's go shopping. If I had $1 for every time someone has asked me to calculate a discount price for them when a sign advertised a certain percent off, I'd be able to buy us both a very handsome gift indeed. In fact, shopping is one of the most common ways that people running loose in society are likely to encounter percents. My wife is an absolute wizard with Macy's coupon. As a high volume shopper there, she gets quite a few coupons in the mail. On one recent mall outing, she found a lovely red strapless number with a selling price of $79. She had 2 coupons to choose from. One offers $15 off any purchase of $50 or more. The other offers 20% off any item. Which was the better choice? Okay, it says here find 20% of 79. So we know 20%, we'll drop the percent sign, move the decimal 2 places to the left, and that will give us 0.20. And then of means multiplication, and then $79. So when we multiply this, this will give us $15.80. That's how much money will be taken off. It says, keep it in mind that you just found the amount the price would be discounted. Which coupon should Kat have used? So the 20% off any item will give her $15.80 off. But here, there's a coupon that says $15 off of 50. So she would get an extra 80 cents by using the 20% off. So 20% off is the better discount because she gets an extra 80 cents. Well, I should put off the price. Okay, number 7. The sales tax in our country is 6.5%. Find the amount of tax on the dress purchased after applying the coupon that you chose and the total cost including tax. Okay, now, with number 7, first thing we would do is take our $79 and subtract our discount. We chose the 20% off, so we would subtract the $15.80, which would give us $63.20. Now we have to figure out how much is paid after you include tax. So you could take the $63.20 and multiply it by the tax is 6.5%. Now we could go off to the side here. 6.5%. We know we would have to drop the percent and we'll move that decimal 2 places to the left. So it'd be 0.065. So we'll multiply this by 0.065. Now when you put this in your calculator, Matter of fact, let me show this in the calculator. So showing this in the calculator, we would have $63.20 multiplied by 0.065. And that would give us 4.108, but we need to round that because we're dealing with money and we need 2 decimal places. So it'll be $4.11. And this is the sales tax. Okay, now, for us to find the final price, we would take the discounted price plus the sales tax, and then that will be our total cost, which would be $67.31. This will be the total cost. Okay, now we will go on to page 9. Well, actually, I'm sorry, page 10. That was page 9. So we'll move on to page 10 and look at problem number 8. It says here, it's common for stores to advertise a certain percentage off, then say discount is reflected in the marked price, leaving you to trust that you're getting the percent off that they claim. Suppose that a refrigerator is listed as 30% off with the sale price of $749. What would that make the original selling price? Okay, so if we look here, we're told that it's 30% off. Now, if you think about this, if you pay the list price of any item in the store, you're paying 100% for that item. So if you take 30% off, you're actually going to be paying 70% of whatever the list price is. So we don't know what that is, so it'll be times X, and that should give us $749. So a 70% of the original list price is equal to $749. So 70% will be changed to a decimal. We get with a percent sign and move the decimal 2 places to the left. So it'd be 0.70 times X is equal to $749. Now, we would need to divide. First of all, we have 0.70x is equal to 749. We divide each side by 0.70. And if we put that in our calculator, so we have 749 divided by 0.7. And that would give us 1,070. So X would equal to $1,070. And that is the original price. Okay, now we go on to number 9. A large latte at Shakey's Caffeine Shack usually sells for the low price of $3.50. But today, Shakey has gone goofy and is offering it for just $3. Wow, why not just give them away? Is this a better offer than the 20% off the coffee shop across the street is offering? So, what you would have to do is this here. We want to figure out which one is the better buy. So basically, we could do this. We could take Shakey's new price, which is $3, and then we could subtract what the original price was, which is $3.50, and divide that by the $3.50. Now this would give us a negative 0.50 all over 3.50. Now don't worry about the fact that it's negative. We'll address that in a second. Okay, so now I'm going to put this in our calculator. So we will have, I don't see the negative sign here. Okay, I found the negative sign is actually the subtraction sign. So it'll be a negative 0.50 divided by 3.50. So we'll just round this to maybe 2 decimal places. So it'll be a negative 0.14, which would be approximately, what is approximately a negative 14%. Now, right now, I want you to disregard the negative sign, but if you look here, Shaky only gives you 14% off. So the 20% off at the coffee shop is better. Okay, now, I know you're probably wondering where I got this formula from. This formula is actually what we have here at the bottom of the page. It's computer percent increase and decrease. So basically, we were doing a percent decrease here because they had the discount from $3, from $3.50 to $3. So it says percent decrease is the amount of decrease divided by the original amount. So it's the new amount, which was the $3, minus the original amount, which was the $3.50, divided by the original amount. Now, if you notice, if you look at percent increase, it has the exact same formula. The only difference between these two is your answer for the percent decrease will come out negative and your percent increase will come out positive. Now, one other thing that I want to show you is this. I usually tell a lot of students this method. I know it says new minus original divided by original, but sometimes I say new minus old divided by old. Sometimes that helps students remember it better, but it's up to you. It yields the same results. Okay, now we move on to page 11. And we go here to problem number 10. Now it says on July 24th, 2009, the federal minimum wage was raised from $6.55 to $7.25. Find the percent increase. Okay, so it was raised from this value to this value. So this is the old amount. This is the new amount. So we want to do the percent increase. So we will have the new minus the old or original divided by the old. The new value is 7.25 minus the old value, which is 6.55, divided by the old value, which is 6.55. Now, when we put this in our calculator, so we'll have 7.25 minus 6.55 divided by, well, if you notice here, it did the division incorrectly, so I have to take that off. Okay, so it gave us 0.7. All right, so now let me go back here and put this parenthesis here. So then I could do divided by, and it would give us the proper division. So it'd be 6.55. So now we'll round this. Let's just round this to 4 decimal places. So this would be approximately 0.1069 when you round this to 4 decimal places. Now we want to write that as a percent because remember it says percent increase. If you're ever dealing with percent increase or decrease, you must write your final answer as a percent. So we will have to move this decimal 2 places to the right, which will give us 10.69, and put the percent sign at the end. Okay, for problem number 11, it says the entry shown in cell D3 is a sample of an Excel formula. This is how Excel is programmed to perform calculations, like percent change, automatically. the equal sign tells Excel that you're typing a formula. The formula in this case is C3 divided by A3, which tells Excel to divide the number in cell C3, the amount of change, by the number in cell A3, the original amount. It says write the formula that appears in C3 and D2. So in C3, the formula would start off with the equal sign, because that's what was told. The equal sign tells Excel that you're typing a formula. Then, since we're going here to C3, we would want to take B3 minus A3. So we would get C3. Because if you look here, 3.5 minus 3 gave us a negative 0.5. So we took B3 minus C3 for the C3. Okay, now we would do D2. We would have our equal sign, and we would have C2 divided by A2. Now, if you look here at D2, this is percent change. So what we would do is take C2 divided by A2, because that's the original amount, which is basically how you would set this up in Excel. Now, we're going to move on to the next page. Now we have here problem number 12. It says a department store advertised that certain merchandise was reduced 25%. Also, an additional 10% discount card will be given to the first 200 people who entered the store on a specific day. The advertisement then stated that this amounted to a 35% reduction in the price of an item. Explain why the store marketing manager is either a liar or bad at math. Show calculations to back up your explanation. All right, so first thing, you get 25% off, and then you get an additional 10% off. So let's do this. Let's take $100, because I want to show you the calculation first. You take 25% off of this. We know $100, 100%. This end up being 75%. So we'll multiply this by 0.75, and this will leave us $75. Okay, now, they tell us to take an additional 10% off. So if we take an additional 10% off, the 75% now is our new 100%. 10% off of that means that you only pay 90% of the $75. So we would end up putting that in our calculator, which I have here. It'll give us $67.50. So this is how much you would end up paying. Now, according to the marketing person, they said it's supposed to be a 35% reduction. So if we go back to the $100 we had originally, so 35% off means that you was only supposed to pay 65% of the $100, which means that you only should have paid $65. So basically, the extra 10% is off the 25% reduction, not the original price. Because if it would have been off the original price, you would get a lot more off of the item. Okay, now, number 13. In promotional materials, a company that increased their workforce from 1,000 to 1,500 workers claimed that they hired 50% more workers. A rival of theirs bragged about decreasing emissions from 1,500 to 1,000 cubic feet per day, claiming a 33% reduction. Which company is lying? Explain. So let's go here. We went from 1,000 to 1,500. So we know that this is the old value. This is the new value. So we would do our percent increase, which would be the new value minus the old value divided by the old value. The new value is 1,500. The old value is 1,000. And divided by the old value, which is 1,000. So this will end up being 500 divided by 1,000, which is 50%. This will give you 0.5, which would be 50%. Now we go percent decrease. Same formula, new minus old, divided by old. Now here, the old value was the 1,500, and the new value was the 1,000. So it'll be 1,000 minus the 1,500 divided by the 1,500. So this would give us a negative 500 divided by 1,500. Now, when you put this in your calculator, which I'll show that here, so it'll be a negative 500 divided by 1,500. And if you notice, it gives you a negative 0 point and repeat in threes. So that is approximately, if we round it to 2 decimal places, this would be a negative 0.33, which is approximately a negative 33%, which is a 33% reduction. So both companies are telling the truth. So neither one is lying. Now we'll jump to our last part of section 1.1, which is page 14, problems 1 through 7. It says, given that 40% is being subtracted from the ticket price, explain why that makes the sale price 60% of the ticket price. Now remember, I told you all this earlier. The original price is 100%. And taking away or reducing by 40% leaves 60%. Okay, number 2. The ticket price can be rounded easily to $50. So you can estimate the sale price by multiplying 50 by 0.6. The easy way to do this is to multiply 50 by 6, which you could do in your head. Then move the decimal one place to the left. Use this idea to estimate the sales price. For what it's worth, I used the procedure about 8 times yesterday while clothes shopping. Okay, so basically, we're supposed to take 50 times 6, which would be 300. Now we know, if we look here, this 6 is actually 0.6, which means it's one value behind the decimal. So 300, we'll move this decimal one place to the left. So it'll be $30. Now number 3. It says, now use the procedures we reviewed in this lesson to find the exact discount price. So we know this is an approximation, it's $30. So we'll take this $47.99, which is up here in the problem. Now is the price of the item. And we'll multiply it by 0.60. And that would give us, when we put this in our calculator, it'll be 28.794. Now we know that this, since this is money, We will round this to $28.79. Now, number 4, would your estimate from question 2 have been good enough for you to decide whether or not you wanted to buy the item? Not for me. Higher amount could make it seem too high. All right, now we go here to number 5, or I'm sorry, page 15, but problem number 5. It says after a round of layoffs, well, let me go back here and explain what I meant by number 4. When you estimate, like this is $47.99, but what if it was $479.90? And then you did 480 and you could overestimate, and then you could decide not to buy it, and then it could turn out that it wasn't as high as your estimate. So that's what I meant by that. Okay, number 5. It says after a round of layoffs, a company that used to have 1,200 employees now has 900. They then issue a press release saying, in spite of trying economic times, we were able to limit job cuts to just 25% of our job force. A couple of years later, they raised the number of employees back to 1,200. This time, they claim we were able to increase our job force by more than 33%. And which press release were they lying? Okay, so now, remember, this was the old, this was the new. So, we have our percent decrease. So it'll be the new minus the old divided by the old, to give us a negative 300 over 1,200, which, when you put in your calculator, it'll give you a negative 0.25, which is a negative 25%. So that means that the workforce went down to 25%, so they was telling the truth there. Now here we're going to do, because we went from 900, which now would be the new old, and then this 1,200 would be new. So we do percent increase. So we would have the new, which is 1,200, minus the old, which is 900, divided by 900. So this would give us, if you look in your calculator, to give you 0.3 with repeating threes. So we'll go to 3 decimal places. So it'll be approximately 33.3%. So we could say that both are correct. Now I would say this. Actually, we should have just rounded to 2 decimal places. Let's just do it like that. So it'll be 33%. Okay, now they are both correct, but let's just really think about this. They reduced it down 25%, and then they took it back to the regular level. Even though mathematically they're correct, we know that sometimes that's a form of manipulation. So let's look at number 6. It says an employer offers a retirement program in which 9.8% of a worker's salary is deducted from their pay and deposited into an investment fund. The company then adds an additional 12% of the worker's salary to the fund. How much would an employee have deposited into their fund in the first year if their starting salary is $43,000? So we start off at $43,000. Now we want to know how much they will put in their first year. So we will multiply this by, it says 9.8%, which is 0.098. Now, when you multiply this in your calculator, that would give you $4,214. So this is how much was put in the first year. Now, number 7. While shopping at Nordstrom's, you pick out 2 pairs of jeans at $49 each and a pair of shoes on sale for $39. Then you splurge on a $95 sweater. You have 2 coupons but can only use one. The first offers 40% off any single item. The second offers 15% off your entire purchase. Which is the better choice? So listen, before we start this problem, we have to assume that 40% off will go to the highest item when it says any single item. So what we would do is this here. You have, let's look at what we have. We had 2 pairs of jeans at $49 each. We have a pair of shoes for $39, and then we have a $95 sweater. So we have a total of 2, 3, 4 items. So the first thing we do, we have $49 times 2, so we spent $98 on the jeans. Then we would add, well, let me put the $98. Then we would add $39. And then we will also add $95. Now, when we add all of this up, it'll give us $232. Okay, now, the first thing I would check out is that 15% off. Since we know that it's 15% off, we can multiply by 0.15. And when we multiply that, that'll give us $34.80. Now, I'm assuming that you're going to use a calculator with this. So it's $34.80. That's how much it is with the 15% off. Now, if we go here to the 40% off, we're going to take the highest value, which here would be the 90. Oh, you know what? I made an error here. This 8 is supposed to be 90. Wait a minute. No, that's right. It is $98. Okay. So the highest value here, the highest single value is the $95. So we'll take the $95 and multiply that by 0.4. Now, when we take the $95 and divide it by multiply by 0.4, that would give us $38 off. So this here, the 15% off of the whole bill, only gives $34.80 off. The 40% off just the $95 would give us $38 off. So the 40% off is the better deal. And that concludes section 1.1. And if you have any other questions, please email me, or we could wait to the big blue button and talk about it.